Okay, what we have here in front of us is a laptop that was sent in by a individual who had this repaired by Precision Division. They had it worked on in the middle of September, and then it was sent out at the end of September, and then we started correspondence in October to actually get it repaired, and well, we got it in the middle of October. So what we're going to do is we're going to turn this on and see what happens with it. Our user is stating that it doesn't function, and well, there's different degrees of non-functioning, so we'll see. Now we have a BIOS screen. This is typical HP splash screen, and you get the hardware failure startup. That's a software problem typical with SATA controller error issues, which are linked to the chipset issues. Now what we're seeing is a screen that says starting Windows. This is a pretty typical screen if it's actually working, but what we don't notice is any actual startup activity. We see no graphics, we see no actual loading menus, we see nothing. So what's happened is this system's actually hung with a SATA controller error issue, which is also indicative of a chipset failure. Now the reason we can tell this is because we have no third light indicating hard drive activity. So what's going to happen is this system will probably sit here until we actually turn it off. There's nothing happening. There's nothing going to happen. It'll sit here and it's just locked up. Now some would say that this is actually a issue that's related to a software failure, but that's not true, because what will happen is we can turn this machine off, we can turn it back on, and what's going to happen due to the overheating is we will see lines on the actual screen through the displays. Now what we're seeing here is no video, which is also indicative of a chipset failure. Now we have the blue lights, we have no video, so this problem tends to be intermittent, but still a problem exists with this machine. Now we can turn it off, leave it off for 5-10 minutes, turn it back on, and we could probably actually get video out of it. We could probably actually get it to go through the whole entire Windows startup again like it did, and then hang. That is indicative of a chipset failure. That is a chipset problem. This machine needs to be reflowed or reballed. So what we're going to do is we're going to take it apart and see what happens, and we'll go from there. So this is yet another thing that we see with these Precision Division machines. We have a actual wireless card. This card happened to be marked in some sort of way, which we actually marked that out. But the screw here, if we can't get a better look at it, is actually drilled out. So this is taking a power drill and actually stripping the screw to where you can't get it out. This screw would have to be cut out, and then this right here is non-existent. In essence, the protection of this is all outward screws look perfectly fine, which you could take these out all day long because they're not stripped or bored. But this actually connects the top part to the bottom part, and you cannot get to the actual motherboard without getting that screw off. So what is this in essence going to say? This says that your warranty is pretty much non-existent. You do not have a warranty. Your warranty doesn't exist because that screw cannot be taken out by regular means. It would have to be disassembled, cut out, broken. Your wireless card is going to have to be pretty much damaged to take it out. All of us who have checked into what a wireless card costs, it costs $10 to $15. So every time a warranty is being performed by Precision Division, he is not paying $10 to $15 to break out the wireless card on your machine to get it repaired. So your warranty does not exist because a warranty can't be performed if the top and the bottom portions cannot be taken out. That's a myth. That's a lie. That is not true. That a warranty can be performed, because if you can't get this card out, you cannot get that screw out, then you cannot get to the motherboard. And to pay $10 to $15 to $20 per machine to break the wireless card out does not make logical business sense when this screw is stripped. Now we're going to proceed and check the rest of the system to see what else we find. So what we have here is pretty much the basic facts. We took this Dremel and had to cut this card out. There's no way around it. When you have a strip screw like that, you have to get it out, and that screw appeared to us to be stripped on purpose. So we had to cut the card physically out, and then take this, and what we're going to do is we're going to unthread that screw with our wire cutters here, and we have chunks of card everywhere. So there's no way around it. That looked blatantly done to keep anybody from working on this machine, and so that no warranty work could be performed on this machine. There's no way that this screw got like that, while all other screws, which we have all the other screws here, while all the other screws kept their threads perfectly fine. There's no way. And this took us a carbide bit running at 35,000 RPMs to cut that wireless card to get that out. So what we're going to do is we'll continue on and see where it goes from here. See what more we find. So now that we have this system apart, we'll continue to take this screw out, and what we notice, to me is no shock, but for all the disadvantages and for all the statements about shims, what we have is yet another fine example, like we have with the D630. We have what appears to be aluminum shims. These flashings with PVC electrical tape actually do more to contain heat. We have heat retention over here, heat retention over here, and what happens is this does more to damage and heat up your chipsets than anything that we can notice. And contrary to this other system that we saw with the D630, we do not see any wires pulled on the actual fan. So I can give this much and say we do not see any stray wires clipped, pulled, or anything like that. But we still see the same ceramic non-insulating compound. We do not see Arctic silver, and we see that on this aluminum shim, because this is aluminum. Probably the same Reynolds wrap or Walmart derivative that you would see in your grocery store, which does nothing. That does nothing to help your machine. This right here does nothing to help your machine. This actually insulates the heat on the actual chip and causes it to overheat. So what we're going to do is we're going to take this apart and then further examine it here in a second. So now that we have the heatsink off and we have the aluminum flashing off, and here's actual TIM. So we have our chipset here. Appears to be undamaged, but what we do see is faint discoloring on this side of the actual fan. That means that this chipset has actually got hot enough to discolor or burn that actual fan connection. And what we also notice is that the old thermal Arctic silver has not been removed. What has happened is cheaper ceramic, not silver bearing thermal transfer material has been placed on top. And by being placed on top, we mean that this, we've almost scraped it all up and it's nothing. There is no new thermal compound on this actual chipset, this processor, to actually pull heat and wick it away from the system. So what we're going to do is we're going to clean these pads on here. We're going to clean this. We're going to actually reflow or reball this chipset here, and we'll reuse the TIM, and we'll discard all this and see what happens. And we'll go from there. So what we have here is thermometer, well, a thermostat checker hooked up straight to the chip, so that we know what temperature this chip is before we start. And what we're going to do is take this fan and hook it up here, and we're going to run a little test on it though. This test is going to show how great without the TIM and what happens to your system in boot up and how hot it gets. You know, just at the very beginning, just to check it. So we're sitting at 67 degrees Fahrenheit, and we'll go from here and see what happens. So what we've done is we've hooked up our fan, power switch, our thermostat, and left our TIM over here, and plugged in the power and left the memory on the motherboard. And what we're going to do is turn it on and see what register we get. So we get it, turn it on. First few seconds we see it climb sky high. We're looking, failure is within the first 10, maybe 15 seconds. So what we have is, without a TIM and without proper thermal transferabilities from the Arctic silver, we have the channel coming from the processor here to over to where the fan is. We're seeing it climb at 100 to 108 degrees. And what happens is, in a reboot cycle, it'll just continue the climb, and the temperature will continue to build on top of it until it actually causes that chip to internally fail. Now this is why we see that this fan, we have the fan here, And this is why that we saw the discoloration on that actual fan, is because the heat coming off this chip goes straight to that fan and causes it to overheat and heat up so much. I mean, we've only had one reboot and it's went from 107 to 114. Turned off, turned back on. Now the temperature is going to climb and build up on top of itself. So from 114 it's going to go to 118, 119, 120, and it's going to continue to build the heat on top of it until it burns up both the processor and the GPU, causes the memory to fail. And this is why we see issues where the system overheats. So from what we're going to do is we're going to turn this off, we're going to reflow it, put the TIM back on it, and then we're going to retest it again and see why that improves and what that does to actually cause better thermal displacement. So now we're putting the TIM, the thermal interface material, back on. And just as a side note for pretty much all the rocket scientists that are out there putting pennies and copper shims on everything to keep the temperature, it cools it down 10 degrees or 15 degrees, I'd like to look at this and realize in my mind that's orange and it looks like copper. And so does this. Note the sarcasm. That is copper pads on your heatsink. That is a great majority. That heat pipe is filled with coolant and is made out of copper with clad aluminum right here. So for every rocket scientist out there, realize that is it's exactly what that is. That's copper boots on there that make it work. So there's no need to put copper shims on there or pennies. So we'll put this back together after we put some thermal compound over here and see what happens as far as the temperature goes. So now we've got this machine hooked up. Everything appears to be fine. We've got it set. Everything's plugged in. So what we're going to do is we're going to turn it on, see what happens to this system. Now notice the thermal interface material is in between the actual chipset and the heatsink. So what we're noticing is that our thermal, it raising in temperature, the recovery is not so great. Before we had quite a climb, but we put the Arctic Silver on there, put the thermal interface material back on there, like so, and our actual couplings down in there, testing how hot. So we're at 88, 87, natural reboot because nothing's happening with the machine. But unlike the previous climb, we do not have the thermal activity like we had. So the greatest deal with this is that the TIM on its own, properly used with the system, actually causes the system to actually regulate its own temperature in a proper fashion. We're seeing the actual thermal recovery where it's dropping, fan's not on, so that means that the system actually is working properly the way it's supposed to with the TIM. So what we're going to do is we're going to turn this machine on now, see what happens. We have tested it beforehand and notice a few indicators that may indicate something. What we'll end up doing is so what happens is this machine's going to start up. It's going to try to go into Windows, and what happens is we're going to get a 007B error. With an 007B error, what happens is this machine is actually having an issue related to the SATA controller drivers. What has happened is it's went from non-emulated to emulated status now that the controller is actually working and the chipset's actually working, and it is actually causing problems with Windows Vista or Windows 7, whichever one happens to be on the machine. So what we're going to do is we'll call this complete, finished, and we'll go from there in the repair.